Hello and welcome to this vodcast. So this picture represents something I'd like you to take into consideration when you conceptualize thresholds, J&D, and Weber's law. They're all interconnected. However, J&D and Weber's law are very connected. They are more so connected than the concept of absolute threshold. Okay, so just keep that in mind, that these two concepts go together. When talking about J&D, you're inevitably going to talk about Weber's law. Okay? Okay, so let's talk about J&D and what it actually is. Let's use an example, though. Let's talk about the fact that we're all riding together in a car, and I noticed that the bass sounds low in your sound system, and I asked you to increase the bass. And it might even be a computerized system where, as you press the button to increase it, these little bars get filled, which indicates that the bass sound is increasing, right? And you can keep the higher, the more they're filled, the more that we are increasing bass, right, in the music. So this isn't a question about how much, whether or not I like heavy bass. It's a question of, as you're pressing that button and the bass is increasing, can we tell the difference? Can we actually hear that the bass is becoming more pronounced as opposed to what it was before? So again, it's how much does a stimulus need to change before we can detect the change. It's about detecting change. And what's the smallest amount of change we need for us to be able to detect? Okay, so what's the smallest amount of difference? You can do this with almost anything. Food comes to mind. I used the example in class of adding sugar to coffee, right? How much sugar do I have to add until I can even taste the sweetness? So it's not a question of whether or not I like things really, really sweet. It's a question of detection of the change, right? Because I might be able to detect that, yes, you added more salt. I can taste that it is saltier, but I want more salt, right? That's not J&D. J&D is about when I can specifically detect the change, right, in the stimulus. Here's where Weber's law comes into play. Weber's law is really cool. Now, Weber was a psychophysicist. Remember that term? He was a psychophysicist. And he actually realized that for each sense, in order for us to detect the change, that they differed. And he noticed that the amount we had to add to something differed. And he also realized that it was a constant percentage that was specific to each sense for us to be able to detect the difference in that specific sense. So, for example, in order to detect a change in sound, right, you have to increase the sound by at least 5% for most people to be able to detect it. Okay? For weight, in order for me to detect that something has gotten heavier, you have to change the weight by at least 2%. So you can see that difference right there, right? That it varies, that it's constant for weight, constant for hearing, but the percentage is different depending upon the sense. All right? So again, for Weber's law, in order to perceive something as different, the stimuli has to differ by a constant minimum percentage. Okay? Not a constant amount. Let's give you an example of this. Let's actually do one here. Sometimes you'll see it written as proportion, by the way, not just percentage. So let's take Courtney and Sue. I actually want you to read this question. We're changing Sue's weight to 25 pounds, her dumbbell to 25 pounds. I want you to actually use Weber's law. We know that for weight, Weber's law is 2%. Do the math, and let's answer this question. Put me on pause, okay? Here we go. So in order for Courtney to at least detect the difference, we have to minimally add 0.2 pounds to her 10-pound dumbbell. In order for Sue to tell the difference, we have to add a little bit more weight, because remember, it's percentage, not amount. We have to add half a pound, and then Sue will be able to tell the difference. Hey, this got heavier. Okay? Now, skip my spider picture. This is really important, okay? So please do not get confused when you read a definition of Weber's law that reads like this. You read this to yourself, okay? So it still is a constant percentage. Okay, it is still a constant percentage. However, we just saw in our example that the heavier the weight in which you start, the more weight you have to add. Okay? The more weight you have to add. So again, the more intense the stimulus, the more it will need to change before we notice the difference. But always keep in mind that that variation is still a constant percentage, meaning that weight will always be, for Weber's law, 2%, regardless of if I'm lifting 100 pounds or lifting 500 pounds. Okay, in order to tell the difference, I still have to increase the weight by 2%. Okay, but we know that 2% of 500 is a lot more than 2% of 100. That's all this is trying to say here when it throws in the idea that the more intense the stimulus, the more it will need to change. It's always a constant percentage, okay? And remember, each sense has its own constant. If you're interested in the spider, we'll have to talk about it in class. Okay, I hope this helped.